Okay, so an example of a curve layout animating here is this hello world. Let's go into the curve layout. So the idea behind a curve layout is you define some points using and those points and tangents create a Bezier curve, which you can read up on if you're interested. And then you position objects along that curve, and it has some interesting options to how to deal with the tangents and then how to deal with the ends of the curve. And so one of my favorite demos that I made, you have these birds kind of flying, and they're flying in a particular path, and you can see that they are going around in different patterns. So here you have them going in this curve and then repeating the curve by inverting the curve. In this case, you just have them going in a line, and then they go in the curve, and then they extend out in another line. I want to show how this demo works. So here's our curve. And what's going to happen is you have, in this case, these balls instead of the birds. They're going to follow this curve in some way. And we can see the curve layout here. These are the points on the curve. So if I move this thing, you can see the value changing in the tangent, because this is one of the tangent points. So when you're creating these curves, you want to check these boxes as needed, because there's a lot of little handles and you don't know what's what. And I haven't found a good way in Unity to create these kinds of 3D movement handles and indicate them in a better way. But if I, for example, lock the tangents, then I can move the curve points around. So I can move this end around, and you can see how the curve adjusts when I move it. I can move this one around. And let's move our objects into the curve. So this start at property determines where the objects are along the curve, where the first object is along the curve. So right now it's at some negative value, but if I change it to 0, you can see it starts at the very beginning of the curve and starts working its way around the curve. As I increase this number, the first object is moving, which is also moving the rest of the objects along the curve. I can mess with how far apart the objects are by changing the spacing value, increasing and decreasing that. And then I can change, I can also say, it's just like the circle layout, I can say I want them to be evenly spaced. So now the first object is at the beginning of the curve, and the last object is at the end of the curve, even spaces between them. Sometimes you want to create some sort of interesting shape or something, so you want to connect the start and end point of the curve, and that's when you would use this evenly connected property, where it's still evenly spaced, but it doesn't put an object at the last spot so that you can connect it back to the beginning. So I can move this here, and it's still, now it looks like it's all connected in some sort of circuit. And you don't have to have tangents on these. You can make these all corners, which would make it into some sort of shape. So you can make a star, you can make a square, whatever you want. Then the final interesting properties are, well, there's rotation, which is not going to do anything to these spheres because they look the same from all angles. But the rotation options are similar to the circle, where you can say they are pointing into the curve, they're going along the curve. One of the fun things that I had a lot of trouble getting the math right for is if you have something like a bird and it's going along the curve, as you can see here, if it's going up at some point, if you go along this curve, it's going to need to go upside down. So that was a fun little thing to solve. How do you make sure that that happens correctly when things are going along the curve? So the before start and after end properties determine what happens when you go before the start point of the curve or after this end point of the curve. And so in this case, I'm just having it repeat on both ends. So as I change the start position, you can see it's just repeating the curve as if there was another curve connected that looked exactly the same. And it can just repeat forever and ever and ever. Another option for it is to stop. So you can say, I'm going to go along this curve till I reach this point, and then the object will just stop at that final point. This is useful if, for example, this point is off screen. Let's say this is the only part of the curve you care about. You can have the objects animate or show up on this part of the curve, and then they just stop when they reach that end. Ping pong is means once you've reached the end of the curve, ping pong back in the other direction. So this is particularly useful if you just have one object, let's say a slider or something, and you want it to go back and forth along the slider. You can have it ping pong once it reaches the end, things like that. And then there is extend as a line. You can say keep going forever and ever and ever, just like that. And you can have, we did repeat and then repeat mirror. So what's this going to do is say, imagine there was another curve connected to this curve that looked just like this curve, but was inverted. So every point is at an opposite point, and every tangent is going in the opposite direction. So now you get it curving in the other way. So that is the curve layout.